Okay, so today we're going to talk about graphing points using Desmos. So first thing to do is just graphing points without using any tables. So to graph a point, we need to put in brackets. So we put the bracket, then we put our point. So say our point is 4, 6, we put 4, comma 6, and then we finish out our bracket. And if we go up to 4, 6, there it is. And if we have a negative value, so say it's -1, 2, so we always start with the bracket, and we put in -1 and 2, and we always end the bracket. And if we move down our point, oh, I'm sorry, I forgot to put the comma, and there is our point. Okay, so now let's try using a table to graph points. So I'll just exit those. So we press add item, we go down to table, and this chart comes up. So we put in our points. So say our first point is 1, 3, and then we put our next point in, which is 2, 5. Oh, that's not working. 2 and 5, and then we just keep going down and keep putting our values. So now we'll do 3 and 6, 4, 6.5, and then we would do this all the way down until the points are complete in the table. So now to graph a line of best fit for this, so we could use our eyesight and probably get a decently close function that would match this, but we can also use something called regression. So regression is using the computer to find a line that best fits this data. So what we do is Y, and then this sign, it's in the top left corner of the keyboard, but we have to make sure we do Y1 because in our table it's Y1. So Y1 equals, and let's do a linear function for right now. So M x1 plus b. And we can't use any numbers. We have to use coefficients like m and b because they can fill in the different values in order to get the line that best fits. So that's our linear function, and now we'll do a quadratic function. So y1, oh sorry, and you can't do caps as well. So y1 regression equals a bracket x1 minus d bracket squared. Oh, why isn't that? Set the bracket squared plus c, and that would give us a point, a line with these values in these spots. So you can do this with pretty much any function as long as you keep the values for the variables as unknown and you let the computer solve for them. And to see how accurate each parabola is, we look at this R2 value. So from my side, we can see that the quadratic function fits this line much better than the linear function. But how we can tell this is that this R2 value, closer that number is to 1, the better the fit of the line for the data. So as you can see, 0.998 is much closer to 1 than 0.45. So the quadratic function is near a perfect fit, whereas the linear function is a not very good fit.